Hi, today we're going to talk about, this is 2016 AB Calculus exam, question number 4. It's a non-calculator question, so you're not using your calculator here. So the question is, it's a very standard kind of a question that they have on the AP exam. Consider this differential equation that's given to us. D over dy equals y squared over x minus 1. The first question is asking us to sketch the slope field. There are 6 points that we have here. It says 6 points. So what we need to do is sketch the slope field at each one of those 6 points. So what we do is we substitute the values of x and y. So our first point is 0, 0. When you substitute 0, 0 in here, you're going to get 0. So you're going to sketch a short segment whose slope will be 0. This point is 2, 0. So if you substitute that, the slope will be 0 as well. So we're going to do that. Now we have this point. This is 0, 1. So when you substitute 0, 1 in here, it's going to be 1 squared over 0 minus 1. So the slope is going to be negative 1. So the slope is negative 1 about that. This is point 0, 2, so it's going to be 2 squared over 0 minus 1, which is going to be negative 4. So it's going to be a little steeper than that. And then for this point, it's going to be, this is 2, 1. So 2, 1, 1 squared over 2 minus 1. The slope here is going to be 1. And then this point is 2, 2. So the slope is going to be 2 squared over 2 minus 1, which is going to be 4. So it's going to be steeper than that. That would give you all the points for this. The important thing is 0 slopes, and then wherever the slopes are positive, they're positive, and wherever they're negative, they're negative. Okay. The second question is, it is asking you to write an equation of the tangent line. We know that f of 2 is 3. And we're trying to write the equation at x equals 2, and we're going to use that equation to approximate the value at 2.1. So all we need to do here is find, so we're doing part B, we need to write an equation of the tangent line. We need two things, the point and the slope. The point is given to us, it is 2, 3. And then we need to find the slope. The slope will be evaluated by using the derivative, 3 squared over 2 minus 1, correct? So it's going to be 9. And the tangent line, the equation of the tangent line is going to be y minus 3 equals 9 times x minus 2. And we want to, so if we rewrite that in this form, you don't have to, but it's going to make things a little bit easier. And then when you're trying to evaluate that at 2.1, so it's going to be 9 times 2.1 minus 2 plus 3. This is going to give you 0.1 times 9 is 0.9. The whole thing ends up to 3.9. Okay? It's a very standard question. There are multiple variations of that, but basically you just need to show that you understand that the slope is going to be determined by the value of the derivative at that point, and then you need to know how to write equations of tangent lines by using that slope and the point, which goes back to algebra 1, and then you just substitute the value of that they give you to approximate the value of the function. So the most challenging part here is part C. This is where they ask you to find the particular solution of the differential equation with that initial condition. This is where you're required to show separation of variables first to even earn any points. And then from there you can go ahead and proceed with that. So I'm going to start it on another sheet of paper. I'm going to copy that equation. So I'm doing part C, so dy over dx is going to equal to y squared over x minus 1. Separate first, that's a must-do step. Separation here will give you dy over y squared equals dx over x minus 1. After that we can integrate both sides. So the derivative here is going to give you negative 1 over, I'm so sorry, the integral here, the antiderivative is going to be negative 1 over y. The antiderivative here is going to be ln of the absolute value of x minus 1. We do need the constant of integration somewhere, so we typically put it on the side where x is. This is usually a place where you're going to use the initial condition. The initial condition is 0.23. So we substitute that to evaluate this, right? So what we're going to do is we are going to make x equal 3, so negative 1/3 equals a natural log of 2 minus 1 plus c. This is going to give you 0 because 2 minus 1 is 1 and the natural log of 1 is 0, which means that c is going to equal negative 1/3. So we're getting negative 1 over y equals ln absolute value of x minus 1 minus 1/3. So by then you're going to earn almost all the points on this problem. It's typically either 5 or 6 depending on our problem, but you still need to earn the last point by actually solving this for y. So it's algebra work. We're going to multiply everything by negative 1. 1 over y equals 1/3 minus ln absolute value x minus 1. And reciprocate that, and y equals 1 over 3 minus ln absolute value of x minus 1. And this problem is done. This is all you need to do here, and you don't have to put that equation. There are many variations how you can write that final answer, but it needs to be solved for y, so it must say y equals that. And again, when you do these problems, it's extremely important that this step here, which is separation of variables, this is an acceptable form too. You don't have to write it like this and then like that. You can just go from that to that, but it does need to show separation of variables, meaning y's need to be together and x's need to be together. Okay. Hope that helps.